All right, welcome to Geometry 1-1. We're going to look at points, lines, and planes. Our first part is to look at points, lines, and planes and how these interact. That's all we're doing for this lesson today. So we're going to start with a point. A point, when we say a definition, these are undefined terms actually. We just kind of have a description or a short definition. But a point is like a location. Okay, it's a location. In our description, we want the fact that it has 0 dimensions. So even though when we draw this dot, it technically has a little width and height, it's representing something with no width or height, 0 dimensions. And we would always label this or name it, named with a capital letter. So for instance, I could name this point capital A, might name this point capital B, or this could be point capital C. So one capital letter. A line is made up of points. So if we were to have an infinite number of points together, this would be a line. I'm going to draw that more like this. Okay. So a line has goes infinitely in 2 directions. Infinite in 2 directions. All right, it has no thickness. It has 1 dimension. So if I had a ruler, I might line that up. And, oh, there's my ruler. And I could line my ruler up. I can't quite figure out how to spin it. I could line my ruler up and measure a distance, and maybe this is 2 centimeters. Okay. Now, something important to represent that our line goes infinitely in 2 directions, we're going to add an arrow here and here. So that is indicates that that actually continues all the way and even off of my page forever. I'm not perfectly straight there. And then keep in mind that in geometry, a line is always straight, something that could be drawn with a ruler, not curved. And we name letters, okay, by 2 points on the line. Now, each point is a capital letter, so I might name this line A, B. I could write this line A, B. I could also draw it as a symbol as A, B, with an arrow on each side over it. So that's a line. We could also use a lowercase cursive letter, so I might call this line M. Then we also talked about a plane. A plane is a flat surface okay, that extends in all directions. So you might think of the ground as a plane. It goes on forever. The thing with trying to draw a plane on paper is that, well, okay, the whole paper is a plane, but typically we might represent a plane by representing a specific portion of that plane. So even though it's not going infinitely in all directions, we can kind of represent that with sort of like drawing a piece of paper. And we have a plane, it has 2 dimensions. If you think about your sheet of notebook paper, it has a height and a width, 2 dimensions. And we name a plane by 3 points. I'll draw that a little neater. By 3 points. Okay, so for instance, this might be plane A, JD. Right? We don't really have a shortcut symbol for this, so we always write out the word plane. We could also, sometimes you'll see a plane labeled with a single capital cursive letter. So I might do a nice cursive B. But that can be a little bit tricky. There won't be a point there, but I could also say plane B. So if you ever wondered why do I need cursive, cursive versus printing is important in geometry. Then we have collinear points. So these are types of points. Collinear points are any 2 points on the same line. 2 points on the same line. Okay. Now, any 2 points can be collinear. We'll see this in class, but typically we're talking about a particular line. So for instance, I could have a line here, and A and B, A and B, A and B are collinear. Okay, any 2 points are collinear. But sometimes you can have a third point. So for instance, C. A, B, and C maybe aren't collinear. So let's say if A, B, and C here. These 3, A, B, and C, are collinear. So I could add C here. A, C, B are collinear. They could all be on the same line. Okay? Whereas non-collinear are points not all on the same line. And we saw this in class. Some of you drew like a triangle, like A, B, and C. There's no way to draw a single straight line that would pass through all 3 of these points. So we would say A, B, and C are non-collinear. Right? Similarly, coplanar are points on the same plane. This can be a little tricky to show, but if this represented my plane and I had A, B, C, and D over here, D would not be coplanar, but A, B, and C are. So I could say A and B and C are coplanar. But they would be non-coplanar, so points not all on the same line. Okay, so if I have my plane, and I had A, B, and C, I had D out here, then A, B, C, and D are non-coplanar. All right, that is our 1.1 Part 1 lesson here, identifying and modeling points, lines, and planes, and whether our points are collinear or non-collinear, and whether points are coplanar or non-coplanar. Have a great day. See you in class.